So this is going to be a review on solving linear equations and working with linear equations on a graph, and all that other good stuff for the quiz coming up on those topics. There's a wide variety of stuff that's covered here, from finding an equation to using an equation to picking an equation out of a graph. So there's a few different skill sets that we're going to hit. The first one here is simply getting an equation from 2 points. So, for example, number 1 here says you have the point 0, 2, and you have the point 1, negative 3, and I want to know, okay, what's the mx plus b, what's the slope-intercept equation of the line that would hit those 2 points? So if I were to graph this equation, I would go through those 2 points and make a nice straight line, and everything would be good. I want to know how can I get that equation just by getting these 2 points. Now, if I had a graph to go with this, I could just plot those points, look at the graph, and kind of deduce what my equation would be. But without the graph, just doing it algebraically requires a few steps. So the first step you want to do in all of these problems is to find your slope, which remember is there m there. So the m in your equation stands for the slope. So the first thing you want to do in all of these problems here is to find the slope of your line. So we're going to go ahead and do that. If you don't remember, the slope equation is m is equal to, it's a fraction. It is y1 minus y2 over x1 minus x2. Now, technically speaking, you could do y2 minus y1 over x2 minus x1, which is usually how it's written. So your y's and your x's are flipped left to right. But it really doesn't matter as long as you have a consistent order. So what I mean by that is, for example, in this case, again, we have 0 is our x, 2 is our y, 1 is an x, negative 3 is a y. Remember, points always go x comma y, just like the alphabet. X first, then y. So one way I can set this up is 2 minus negative 3. y1, first y, minus the second y. And then on bottom, I would do the first x minus the second x. Now, I could have done negative 3 minus 2, and then 1 minus 0. I could have done it that way. But if I pick 2 to go first in the top, that means 0 has to go first in the bottom. And if I pick negative 3 to go first in the top, that means positive 1 has to go first in the bottom. It has to go in that order. Otherwise, you're going to get the wrong answer. So it doesn't really matter the order so much as long as you keep consistent with what point you put first on each side. So if we solve this out here, again, minus negative, remember this means a positive, so this means big plus. Excuse me. 2 plus 3 is 5. I'll make that 5 a little bit better there. There we go. And then 0 minus 1 is a negative 1, not a positive 1, because remember you're doing 0 minus 1, so nothing, take away 1, is a negative 1. And this just turns out to be a solid number of negative 5. So that is our slope. That's our m. So we found 1/2 of our equation. Remember, our equation is going to be y equals some number, m, times x, plus some other number, b. And if you don't remember, b is the y-intercept. It is the point where the line crosses the y-axis. So if you're looking at a graph like this, the b value is the point where the line crosses the y-axis right there. So to find b takes a little bit of work. Now, there is a special case in this one. Remember, your b is the y-intercept, and the y-intercept always has the coordinates 0, comma, something. The y-intercept will always be 0, comma, something, and you will always have only one y-intercept for each line. So that means that if one of your points is already 0, comma, something, they are now your y-intercept. If we go back here, 0, comma, 2. Well, I automatically know that 2 right here, that's my y-intercept, that's my b value, because it's 0, comma, something. That's the point where the line crosses the y-axis. Because remember, any point on the y-axis is 0, comma, something, because there's no x-coordinate. Or the x-coordinate is 0, rather. So I can actually just skip the entire half of this problem and just say my equation is y equals m, which is negative 5, x plus b, which is just positive 2. And that's my answer. So it helps to be on the lookout for this trick. It won't happen often if your teachers don't give it to you that often. But when it does happen, it really shortens up your work. So all you need to do in this case is find the slope, pick out your b, and then put it as an equation. Now, what happens when you don't have that trick? Well, then we go to this next one here. Draw a barrier here. So this one starts the same way. We need to find my slope. So let's go ahead and find my slope. I'll do, this will be my y minus y, so negative 2 minus 5, y2 minus y1, or y1 minus y2, however you want to think about it. And then x minus x, so negative 4 minus negative 3. We do some arithmetic here. Negative 2 minus 5 is negative 7 because you're taking away 5 from already taking away 2. You lose 2 and then you lose 5 more. And then remember, this is a big plus. So negative 4 plus 3 is a negative 1. And negative 7 over negative 1 is just positive 7 because a negative over a negative is a positive. So there's my slope. That's my m. Halfway done. Now I need to find my b. I don't have a shortcut in this case. So if you don't have a shortcut, which is what will happen often, here's what you do. You have to pick a reference point. So in my case, I'm going to pick this one because it has a positive number in it. So negative 3, 5 is my reference point. And remember, this is the equation I'm using. Y equals mx plus b. What you want to do is you want to find out what b is, but you can't do that unless you know y, m, and x, because you can't solve for an equation if there's two variables or more. You can only solve if there's only one variable. Well, I already have an m. I already know what this number is. I need to pick a temporary number for x and y. I can't just pick a number. It has to be a number that I know works. So the number I plug in for x, the number I plug in for y, I have to know that they go together and that they work together. And luckily, this point means they do, because this point is on the line. If I know that this point's on the line, because it tells me that goes through the following points, then I know that these two pairs would work, that this x would work with this y. That will work in the equation because it tells me that the line has to go through this point. So this is going to be my temporary x, and this is going to be my temporary y, while I solve for b. So my equation is going to look like this. 5 equals 7 times negative 3 plus b. So I plug in a temporary number for x, I plug in a temporary number for y, I plug in my m value. Now I just have a b variable to solve for, and I can solve for just the b variable. And that's what I'm going to do. 7 times negative 3 is negative 21 plus b equals 5. And then to get rid of plus 21, I'm going to add 21. And I get 26 is equal to b. So my final equation, now this time my y and x can go back to being y and x, because the only reason I plugged these numbers in is because I didn't know my b value. Now that I know my b value, I'm going to go back to the general form of this equation, which means that I'm going to have y and x staying y and x, and have y equals m, which is 7, not 5. Almost typed the wrong number in there. M x plus b. And that is my final answer. That is my final equation. So again, takes a while to do if you don't have the shortcut, but it is doable. Another few without the shortcut here, just make sure we got them down. Again, find my slope first. So y minus y, make sure you put the y's on top too. A very common mistake is, if you're not thinking too well, is to put the x's on top rather than the y's, because the x's come first to the point, but they're going to go on bottom of the fraction, so it kind of messes people up. X minus x. Also be careful of your negatives, of course. It's subtracting a negative, so make sure you put the double negative in there. This is one big positive, so it'd be 6. This is also one big positive, so negative 2 plus 5 would give me 3. So this would end up being a nice even 2. Now I don't have a shortcut, so I'm going to have to pick a reference point. In that case, I'm going to pick this one because they're smaller numbers. So this is going to be my reference point, negative 2 comma 2. So my equation is going to be y, which is this 2 here. So remember, this is y and x. So y is equal to m, this one over here, times x, this right here, plus b. Let's see here. This would be negative 4 plus b equals 2. And then you add 4, and you get 6 is equal to b. And so I get y equals mx plus b. And that is my final answer for that one. So it goes pretty quickly once you get the flow of it down. You just have to remember to do all the steps, which takes a while. Last one here. We have y minus y, so 1 minus 3, x minus x, so 5 minus negative 5. Let's see here, 1 minus 3, that's negative 2. This is one big plus again, because there's two negatives, so that's a 10. So this would be negative 1/5. It's a fraction, but we can do it. I'm going to pick this one over here because they're both positive and they're both small as my reference point. So 5 comma 1 is my reference. So y is equal to m times x plus b. That is a 5 there. Let me make that 5 a little bit better. There we go. And then I solve. So negative 1/5 times 5 is negative 1 plus b equals 1. And then plus 1, so you get 2 is equal to b. So my answer is y is equal to negative 1/5 x. That's a 5 there again. Sorry, I can't make my 5s today. 1/5 x plus 2. That's my final answer for that one. So again, the shortcut really helps if you have it, but if not, it's perfectly doable. It just comes in two stages. Find your slope first, pick a reference point, and then plug that into the equation to find your b, and then write your final answer as the final equation. So 4 steps if you want to pick apart each one there. This will probably take the longest part of all the problems here, just because of the amount of work that's needed. But once you get used to it, it goes by pretty decently. So moving on to some of the other ones here. This is a point slope. So this is basically finding another type of equation for lines that go through points. So again, I have these 2 points in the graph. I want to figure out what line goes through them. And so I want to figure out this type of equation here. So this is called the point slope equation because it uses a point and it uses a slope. So the y and x are just like before, but the y1, the x1, and the m obviously still is a slope, but the y1, the x1 are basically your reference points. It's kind of like an incomplete slope-intercept form. So remember what we did before, these are slope-intercept equations, y equals mx plus b. These are going to be point slope equations, which is, again, kind of like an incomplete slope-intercept form. It's just another way of writing how a line would look algebraically. These actually go by a lot bit faster. So first we need to find our slope, obviously. That's the first thing we usually do for all these problems. So find our slope, same way. Y minus y, so 5 minus 8. X minus x, so 4 minus negative 3. 5 minus 8, that's going to be negative 3. 4 minus negative 3, so the one big plus here, so it's going to be 7. So negative 3/7 is my slope. So I actually don't have to solve for a b here at all. So this is how, there's actually 2 possible answers for each of these. I'm going to show you twice on this one, and the other ones I'm just going to pick one to do. So one way you could write this, remember it goes y minus a y coordinate is equal to m times x minus an x coordinate. Now what you choose as your y and your x coordinate can be any one of the points that you want. So let's say I pick this point here as my reference point. So I still pick a reference point. My answer is going to be y minus 5 is equal to m, which is negative 3/7, times x minus 4, which is my x coordinate. So 5 goes here, 4 goes there, and the slope is still in the m spot. So this could be one possible answer you have. Another possible answer that's equally valid is y using this point over here. So y minus 8 is equal to negative 3/7 times x minus negative 3. Or if you want, you can write plus 3 if you want. Both these answers work. Both these answers are correct because they both use the point and they both use a slope. So as long as you pick pairs of points, so I can't pick like 8 and 4. I can't do that because 8's over here and 4's over there. But as long as I pick points in pairs and I use each number in each pair, then I can have a correct answer. Then I have a correct answer. So with these, all you need to do is find your slope, pick a reference point, and just remember to plug them in the right spots. The rest of the ones, I'm just going to do one of the answers just because it's easy to see the next one. So, but first we need to find our slope. So 7 minus negative 2 and negative 1 minus 8. So this will become a 9 on top and a negative 9 on bottom, and so my slope is just going to be a negative 1. So one possible answer could be y minus 7 is equal to negative 1 times x minus -1. I could also do minus -2 and minus 8 here if I wanted to. I'm just choosing not to. So the next one here, again, slope first. So 7 minus 3 over 5 minus -1. This becomes -4. 5 minus -1, again, means add, so you get 6. Reduce this fraction, you get -2/3 if you divide them both by 2. So 4 divided by 2 is 2, 6 divided by 2 is 3, and then you keep the negative. So I'm going to pick this as my reference point. So it'd be y minus 7 is equal to -2/3 times x minus 5. Again, very short and sweet problems. This one has a bunch of negatives in it, so I have to be careful. -5 minus -15, and then -3 minus 3. So this, again, becomes one big plus, so it's going to be +10. -3 minus 3 is going to be -6. Again, you lose 3, and then you lose 3 more. Divide both these by 2, you get -5/3. And remember, the negative applies to the whole fraction, so if I want to put the negative on top instead of at bottom, I can. I'm going to pick this as my reference point, just to show you some things you can do with negatives. So y minus -5 is equal to -5/3, my m. Whoops, too far out there. Try that again. -5/3 times x minus -3. Now, if you want to clean this up a bit, you could say y plus 5. Y plus 5 is equal to -5/3 times x plus 3. Both of these are the exact same answer. Both of them are correct. And of course, you could do the 3 and the -15 as well if you wanted to. So these problems go a lot simpler than the slope-intercept problems. These are just a different way of writing the equation of the line. Now, next few deal with graphs. So this one says write the slope-intercept and the point-slope form of the graph of the line below. So slope-intercept, remember, requires an m and a b. That's why it's slope-intercept. M is the slope, b is the intercept. So we need to find both of these on the graph. Well, my intercept's right here. That's where it crosses the y-axis. So this point right here is 0, -3. That is my b, or specifically the -3 is my b. That's where it crosses the y-axis at -3. Now I need my m. Let me make that 3 a little bit better. I can't write my numbers today for some reason. There we go. Now I need my m. So my m, remember, is the slope. And the slope is the rise over the run. It's how far up and how far over do you have to go to get from one point on the graph to another. Well, I already have kind of a base point here. So this point right here, my y-intercept is also still a point. My y-intercept counts as a point itself. So this could be one point. And then I need another point on the graph to jump to. And it has to be on the graph. So this point right here looks to be on the graph. That's 7, 1. So I want to figure out my rise and run to go from here to there. So my rise is 1, 2, 3, 4. 4 jumps up. And 1, 2, 3, 4, 5, 6, 7. 7 jumps over. So my slope is rise over run. That's my slope. That's my m, 4/7. I have to go up 4 and over 7 to get from one point to the next. And the reason I chose this point instead of, say, this point is because I don't exactly know where this point is. This looks to be more than halfway up from -2, but I don't know exactly how far up and over I have to go. I can go up 1 and maybe 3/4, and then over 1, 2, 3 maybe. So it's a little bit hard to tell. So you want to pick points that are very easily seen and very easily graphed already when you do your jumps. So my slope-intercept equation would just be this. Y equals m x plus b. Or you can just write -3 instead of plus -3 if you want. So that's all that is. So the slope-intercept from a graph is pretty straightforward. Find out where it crosses the y-axis, and then find out your jumps from one point to the next. Point slope requires a slope, which we have here, 4/7. We already did that. And it requires a point. That's where we get the word point slope from. So I need a point to act as my x1 and my y1. Well, let's just pick this point right here. This point that we just found before is 7, 1. So that is going to act as my x1, y1 reference point. So my point slope form is y minus y1 is equal to 4/7 times x minus x1. And that is my point slope equation. So again, pretty straightforward on the graph for the point slope as well. Find your slope, which you should have already, and then just pick any point you want on the graph to fill in for your x and your y spots. Again, I could have chosen this point, but I don't exactly know how far up it is. It looks to be about negative 1.25 maybe. I'm just not sure. So you do have to remember the formula for it. So this is the formula for the point slope, but once you found your m on the graph, it's just a matter of picking a y and an x number to fill in for these spots here. So slope intercept, find your slope, find out where it crosses the y-axis, then build your equation. For the point slope form, find your slope, pick a point on the line, and then fill in your equation there. All right, last little bit here. So this is going to a word problem here. So cab company makes Y dollars for driving X miles. They give you the equation for the profit. What is the y-intercept and what does it mean? So the y-intercept, remember, is when x equals 0. That's the definition of a y-intercept logistically, is when the x coordinate is 0. That's your y-intercept. So I'm looking at my equation here. I want to say, okay, what is this? What is y when x is 0? What would y be if x was 0? Well, let's find out. 0.95 times 0 plus 3. If I want to know what happens when x is 0, I'm just going to plug in a 0 for x. Well, 0.95 times 0 is just 0, so this goes away. So I'm left with y equals 3. So this is my y-intercept, y equals 3, or 3 if you just want to say 3. What does it mean in the context of the problem? So what does this 3 actually mean? 3 what? Well, in this case, y is the dollars they make for driving x miles. So that means when you drive 0 miles, you make $3. So this is what we'd call $3 flat fee. This is how much you're going to pay just for simply getting in the cab. Even if you don't go anywhere, even if you go 0 miles, you're still going to pay $3. So if you go like 2 feet, you'd still pay at least $3, even if you didn't go a mile. So the y-intercept numbers are usually numbers that either tell you where you're starting, or tell you your flat fee, or tell you your one-time cost. They're numbers that just happen once. So I'm not going to pay $3 every single mile. I'm going to pay $3 once as a flat fee, and then another 95 cents every mile after that. So y-intercepts are usually flat fees, starting amounts, initial values, one-time costs, that sort of thing. What is the x-intercept, and what does it mean in the context of the problem? So the x-intercept is a little bit trickier. The x-intercept, like the y-intercept, is when y is 0. So the x-intercept is when the y is 0. But let's find that out. Plug in 0 for y and see what is x. This is going to take a little bit more work. So we subtract 3 from both sides because we want to figure out what is x. I can't have stuff cluttering the x side. I want to figure out what x is. So negative 3 is equal to 0.95x. And then divide by 0.95. Divide by 0.95. And so it's going to be a nasty little decimal, but we can make do. Negative 3.16, if we round it off, is my x-intercept. So this is what I get when I have 0 for y. Now, what does it mean? This one's a little bit more odd. So remember, y is dollars and x is miles. So this says when I pay $0, I'm going to go this many miles. So this is negative 3.16 miles for $0. So if you want to get in the cab and you say, I'm going to pay nothing, you'd go negative 3.16 miles. Now, can you go negative 3.16 miles? Obviously not. So that's why this doesn't make sense, because the cab company is not going to drive you when you pay $0. So if you say, I'm going to pay you $0, the cab is not going to actually drive you anywhere. It's not even going to move. So even though context-wise this number doesn't really make sense, mathematically that's what it's actually saying, is that if they were doing it pure mathematically, they'd have to take you negative 3.16 miles if you say you're not going to pay anything. But since they can't do that, since you can't go a negative mile, they just don't go anywhere. So contextually it's kind of messy, but mathematically the value is what is x when y is 0. So plug in a 0 for your y, solve the equation, and get the x number out of it. Now the slope is more straightforward. The slope is simply, remember, this is still mx plus b form. Y equals mx plus b. And my slope is just the m. So my slope is 0.95. Now the slope has a special little notation. The slope is y per x. So the slope is the y value per x value. So what I mean by that is that this is $0.95 per mile, because it's y value to x value. The y value is dollars, the x value is miles. So this is $0.95 per mile. You're going to pay $0.95 for every 1 mile that you go. So this is the cost for 1 mile, or the cost per mile. So slope's definition, slope's context usually involves the word per. It's some amount per some other amount. In this case, dollars per mile. And it's always y per x. That's how the slope works, is the y unit per x unit. So if you're trying to describe what the slope means, you're going to have to work that word per or for in there somewhere. So the last one was a little bit of a word problem deciphering one, a little bit different than the other ones, but still very doable. So that's it for this review. Again, there's a lot of different parts to it, but they all revolve around knowing how what your equations mean, knowing the format of the equations, knowing what each value means, and knowing how to describe it. Hope you enjoyed the video. Have a good day.